Have you ever wondered why memory foam seems to remember the shape of your body moments after you get up? People talk about memory foam like it has a brain, but the truth lies in chemistry and physics, not consciousness. In this video, we're going to break down exactly what makes memory foam behave the way it does, from the molecules inside it to how your body heat and pressure change its shape. By the end, you'll understand why it hugs your curves, why it's slow to bounce back, and why we call it memory foam, even though it doesn't think at all. Let's get into it, right here, on History of Simple Things. At its core, memory foam isn't magical. It's a type of polyurethane foam that's been engineered to behave very differently from the ordinary foams you find in a couch cushion or camping pad. While most foam materials spring right back when you press them, memory foam is made to be viscoelastic, meaning it combines viscosity and elasticity in a single material. Viscosity refers to how much a material resists flow or deformation, and elasticity is its ability to return to its original shape. In memory foam, these two properties are balanced in a way that makes it slow to deform and slow to return, giving it that sink-in feeling that so many people associate with comfort. The reason memory foam behaves this way goes back to what it's made of: a network of long polymer chains linked together in a three-dimensional web. When you lie on memory foam, your weight compresses these chains and pushes air out of the open cell structure inside the material. Because the foam is designed with increased viscosity, the molecules don't snap back immediately like in other foams. Instead, they rearrange slowly under pressure. This molecular rearrangement, combined with the foam's tendency to resist quick movement, is what makes the indentation stick around for a few seconds after you lift off. This phenomenon, slow deformation and slow recovery, is the scientific reason we use the word memory here. A big part of the experience of memory foam is that it feels firmer when you first touch it, and softer once you're lying on it. That's because memory foam is temperature sensitive. At colder temperatures, the polymer chains are stiffer and less mobile, so the foam feels firmer and slower to conform. When you lie down, your body heat warms the foam surface, which lowers its viscosity and allows the polymer chains to move more easily. That makes it softer and more responsive to your shape. In everyday terms, this means the foam molds to you more deeply where your body is warm, and it takes a few seconds to activate that contouring effect, giving you a personalized fit. So why does memory foam take its time to bounce back? The answer is in the physics of viscoelasticity. When you press into the foam, several things are happening. Air is being squeezed out of its open pores, internal surfaces stick together briefly, and the polymer's motion is limited because it's near a threshold called the glass transition temperature, the point at which the material switches from a rigid to a more rubbery state. These mechanisms all resist quick movement, so when you remove the pressure, the foam doesn't snap back instantly. Instead, it slowly relaxes and redistributes its internal stresses, which is why you see the shape fade only after a few seconds. This time lag effect, scientifically known as hysteresis, is a defining part of why memory foam feels different from ordinary foams. Memory foam wasn't invented in a mattress factory. It was developed by NASA in the 1960s to improve aircraft seat cushioning. Engineers needed a material that could absorb impact and support pilots under high forces, which meant it had to deform under load, but dissipate energy rather than bouncing back like a trampoline. The resulting slow spring-back foam was perfect for this purpose. Later, in the 1970s and 1980s, the technology was released to the public and adapted for medical cushions, sports equipment, and eventually mattresses and pillows. From cockpit to bedroom, the core innovation remained the same: a foam that responds to pressure and heat in a predictable, gradual way. Memory foam's behavior isn't just about the moment you lie on it, it also changes subtly with long-term use. Over months or years, the foam gradually compresses in areas where pressure is consistently applied, creating a personalized contour that matches your body shape. This doesn't mean it remembers like a brain, but it does slowly adapt at a structural level, as repeated stress slightly rearranges the polymer network and cell structure. Some high-density foams retain this shape longer and provide durable support, while lower-density foams recover more fully but wear out faster. Understanding this long-term adaptation helps explain why older mattresses feel different than new ones and why some pillows or seat cushions can feel perfectly molded to you. It all comes down to memory foam's viscoelastic polymer structure, its temperature sensitivity, and the way its open cell matrix responds to pressure. Your body heat warms and softens the foam, allowing the polymer chains to move more freely, while your weight compresses the material to create a comfortable contour. When you lift up, the foam doesn't spring back immediately. Instead, it slowly relaxes back to its original shape, creating that signature memory effect. There's no conscious memory at work. It's purely the result of physics and clever engineering. Over time, repeated use can even subtly mold the foam to your body's habits, which is why older mattresses and pillows often feel perfectly shaped for you. Understanding this combination of science and design helps explain why memory foam became such a revolutionary material for sleep, comfort, and support. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.